Okay, in this section 10.5, what we're going to do is put a lot of ideas together. We've introduced ourselves to radicals, seen a couple of different ways to work with radicals, whether fractional exponents or with radical notation, multiplied them, divide them, started to simplify them, and of course the two big missing operations is adding and subtracting. Then that just builds up more new material. So adding and subtracting radicals, it's basically this simple, I guess you could say, because it comes down to the concept of combining like terms. So let's kind of consider the situation where I have two terms that are not like, right? So 2x plus 3y, back in chapter 4, we would just leave that alone. Same thing with 2x squared plus 3x. They're not like because the variable part is not the same, right? This is x squared and this is an x. So if anything, we could factor it, but we can't actually perform the addition because they're not like. As opposed to if I do have like terms, right, 2x plus 3x, the variable parts are the same. I'm doubling x, I'm tripling x, so all combined, what we have is 5x. And then same thing here, the variable parts are the same, so we're doubling up x squared, we're tripling up x squared, so combined, how much do we have of x squared? 5x squared. So it turns out that to add and subtract radicals, we basically use the same idea. We have to have the same radical. So in my first example, I have the square root of x and the square root of x. So we have x, the square root of x one time, we have the square root of x another time. So how many times are we adding x to each other? 2 times. So that would be 2 times the square root of x. Of course, that would be similar to if we had x plus x, right? Back in the day, we would say that's just 2x. I'm adding x to itself 2 times. So here I'm adding the square root of x to itself 2 times. So yeah, it's that simple. We just basically, in order to add and subtract, we need the radicals to be the same. In the next example, we have 3 times the square root of 2, and we're adding 8 times the square root of 2. So these two terms are similar because they have the same radical part. So we have the square root of 2 3 times here. It's 8 times here. So how many times do we have it together? Well, 3 plus 8 is 11. So we have 11 square roots of 2. And again, this would be similar to something like if I had 3y plus 8y. Back in the day, we called that 11y. So very, very similar concept. Unlike the polynomials, though, when we run into a situation like this next one where we're adding and I see a cube root of 27 and a cube root of 3, we initially think, well, I can't add. However, what we've learned to do is we've learned to at least simplify. So before you make that declaration that we can't add, try simplifying first and see if that doesn't move the ball forward. So the cube root of 27, this is basically the cube root of 3 cubed plus 3 to the third. The 3's will actually divide out, right? So we have 3 plus the cube root of 3. So this is one of those situations where even though where they don't start as like terms, even when I simplify, they're still not like terms. So we would have to keep that as is. Again, it'd be like having 2x plus 3y. That whole expression, we can't perform the addition. We just have to leave it alone. So again, the rule of thumb is when you initially don't think you can do it, simplify as much as you can. And then at that stage of the game, if you still can't simplify, you still can't simplify. So that happens from time to time. Next one, we're adding 3 radicals together. And again, they're all different at the moment, but we can simplify this. 8 breaks down into 4 times 2. 18 is 9 times 2. And 50 is 25 times 2. So if I kind of start looking at their factorizations, the square root of 4 we know to be 2, and we have square roots of 2. The square root of 9 is 3 square roots of 2, and the square root of 25 is 5 square roots of 2. So initially the idea is, well, I can't add, they're not like, but we go through a round of simplification and it turns out that all these radicals are the same. So combining it all, 2 and 3 and 5, we have a total of 10 square roots of 2. So again, when you run into a situation where you don't think you can add, simplify first. And then in this case, we can get the job done. Here, we couldn't. Let me throw some variables at you. So initially, we have a 2 times the square root of x cubed, and then we have 10 times x times the square root of x. Again, when we had taken an initial look at this, they're not like terms. They're very different. However, we've learned how to simplify that. Let me do it off to the side here. So x cubed, again, if I use the shortcut, 2 goes into 3 one time with the remainder of 1. Or you can just think of this as x squared times x. There's my matching, so we have that. So this breaks down into 2x square root of x minus 10x square root of x. So now my variable parts are in fact the same. So what's 2 take away 10? That's negative 8. And of course we have that variable part. So again, initially the answer was like, well, I can't. But we take some time to simplify using some old ideas. And it turns out that we actually can combine my like terms by subtracting. Last problem, again, we're subtracting. When we take a look at this radical and this radical, they look different. They're not the same, but we can do a simplification. Again, remember, we can't break up a radical over a sum. But what I can do is factor, right? So if we use a GCF, that factors as 4 times x plus 7. And we're subtracting on the back end, I can factor out a GCF of 9 and get x plus 7. So you can start to see they're starting to become alike. What's in the way is the 9 and the 4. However, we know the square root of 4 is 2. So we have 2 times the square root of x plus 7 there. And then the square root of 9 is 3. And we have x plus 7. So it's okay to, what I'm doing is breaking up the radical over a product, because that's how we multiplied radicals there. So let me kind of show that preliminary step. So breaking up a radical over a product is good. Over a sum, it's not. We never learned a rule. There is not a rule for that. But for multiplication, there is. Okay. Now what we take a look at, notice that the radicals are the same. They're both the square root of x plus 7. So I have 2 of them. I'm taking away 3 of them. So technically I have negative 1 times the square root of x plus 7. Of course, that's just probably going to be written like that in the answer in the back of the book. All right, so it comes down to, again, when we're adding and subtracting radicals, we're basically combining like terms. If we've got them, we can go to work. If we don't have them, we do some simplification and see if we can get the job done. All right, so let's build on this topic on to the next video.